Hi, engineers. We've come a long way in our journey. We've explored circuits, switches, motors, electromagnets, and more. Today, we're going to bring it all together with one final component, the speaker. Here's your challenge to start. Make the speaker make noise. That's it. How'd you do? Were you able to figure it out? Like me, maybe the first thing you did was you connected your speaker block to your battery. Did that work? I wasn't able to hear anything. Why do you think the speaker didn't make any sound when we connected it directly to the battery? In this final segment, we're going to learn about sound. How is it generated by a speaker, and how can we use our circuit knowledge to build something that makes sound? By the end of this video, you'll be able to describe sound by its wave characteristics of amplitude and frequency, explain how a speaker functions and makes high and low frequency sounds, and learn how to control the amplitude of sound waves using the components in the kit. Before we understand speakers, we first need to understand sound. Sound is energy that travels through molecules in waves. The waves can be really tall or really small. They can be really long or really short, or they can be any combination. These characteristics impact how the sound sounds. Amplitude is how big the wave is. A higher amplitude means a louder sound. A lower amplitude means a softer sound. Frequency is how fast the wave vibrates. How fast is it going up and down? Higher frequency means higher pitch. Lower frequency means lower pitch. Can you describe this sound using amplitude and frequency? This sound has a low amplitude. It's very quiet, but it has a high frequency. It's a very high pitched sound. So we would say that this sound is high frequency, low amplitude. What about this one? How would you describe this? This one's pretty loud, so we'd say it has a high amplitude. It's also really high pitched, so we describe it as having a high frequency and a high amplitude. And now, what about this last one? That's right. It's very high amplitude and very low frequency. So now that we know how sound works, how does a speaker make sound? Well, speakers are actually kind of similar to motors. Inside the speaker is a coil of wire attached to a thin paper or plastic disc called a cone. Behind the coil is a strong magnet. When electricity flows through that coil, any guesses what's going on? Yeah, it's going to create a magnetic field. But this time, instead of spinning like a motor, the coil is just pulled towards the magnet. The attached cone also moves with it, pulling it back into the speaker. The power then reverses directions, which flips the magnetic fields and pushes the coil and cone forward away from the magnet. When this happens hundreds or thousands of times a second, it creates a wave of energy that travels to our ears. We sense the wave as sound. The faster the changes in direction, the higher the frequency or pitch of the sound. Similar to the way motors convert electricity into motion, speakers convert electricity into motion, which then causes sound waves. I don't know about you, but that still leaves me with one question. Why did the speaker not work when we hooked it up to the battery? That's because the speaker doesn't just need electricity, it needs a pattern of electricity that's going to turn the coil on and off really quickly. That's why your kit includes an integrated circuit block that generates that signal. An integrated circuit is a small chip that contains a pre made circuit. In this case, the circuit generates a siren signal when we hook it up. To use the integrated circuit, it's important for us to pay close attention to the polarity and understand which terminal is designed to be connected to the positive and negative sides of the battery. This block has four terminals. One says power. That one gets connected to the positive side of the battery. On the same side, it also says ground. That one's going to get connected to the negative side. The other side of the block has one part connects to the speaker and the other part connects back to ground. Let's go ahead and hook these up with the speaker and a couple wires. We can now hear the siren sound playing. I can describe the sound as having a consistent amplitude, the volume's not going up or down, but it has a high, then low frequency. It's got a high pitch, and then a low pitch, and then goes back to the high pitch. Let's go ahead and try changing the amplitude of the waves. We'll increase or decrease the volume of the speaker. In order to increase the strength of the wave, the speaker cone needs to move more. That will make the sound louder. In order to decrease it, we want the cone to move less. That will make it softer. Based on what we learned about the motor, do you think that we can make the volume louder? Well, just like the motor, we won't be able to increase the volume because we need to increase the voltage. Without a resistor in line, it's already at max volume. Let's go ahead and hook up the potentiometer, though, and see what we can change. Which diagram do you think shows the best place to put the potentiometer if we want to have volume control? Let's go ahead and try each one of them out. Because I want to only impact the voltage to the speaker, the potentiometer has to be in a series with that and not in a series with the IC block. That means I need to put it in this parallel loop after it. Go ahead and pause the video now to try it on your own. Amazing job. In this video, we learned how to describe sound by its wave characteristics using words such as frequency and amplitude. We explained how a speaker functions and makes high and low frequency sounds. And we learned how to control the amplitude of our sound waves by installing a potentiometer as a volume control knob. Do you want another challenge? We know we can use the photoresistor in order to adjust the voltage to certain devices. Can we do the same with the speaker? Can you think of a use for us to be able to control the volume of a speaker using light? Go ahead and come up with your own invention, a reason why we might be able to use light in order to control the volume of a device.